Hello, welcome to the econometric class. We were discussing econometrics from last 6 months, and we almost completed, or we have completed the portion from basic econometrics part. And now you have entered into the last semester of your program, and in this program you have an elective paper from econometrics. The paper titled is Advanced Econometrics. So in this Advanced Econometrics paper is the continuation of the econometrics ideas or concepts that we were discussing in the last semester. Okay, so in this uh, portion or in this subject, we are not going to learn new things, but we are continuing our basic ideas into further advanced level. Okay, yes. So as I told you before, the econometric classes is cumulative in nature. Okay, so if you don't know the assumptions, or if you don't know the basic understanding of the OLS, then learning econometrics will be very difficult. But I know that you are all learned almost all the basic concepts, and many of you have very good and thorough knowledge in econometrics and how to do the econometric methodology practically. Okay, yes. So in this advanced econometrics paper, we have 6 chapters. There are 6 modules. The first module is deal with simultaneous equation models. Okay, so the simultaneous equation model is, as you have learned in mathematics, there will be 2 equations. Okay, so far in our basic econometric classes we have learned only 1 equation, but in economics there are in certain cases there are joint determinants. That means there will be 2 equations, and these 2 equations we have to estimate simultaneously. Okay, so as in the case of consumption function, as in the case of ISLM models, okay, and in the case of macroeconomic equilibrium, in all these cases we have more than 1 equations. Okay, so this chapter deals with how we can estimate a model with more than 1 equation. Okay, yes. Second chapter deals with dynamic econometric model. In basic econometric classes, the last chapter we have started with this dynamic econometric model. The dynamic econometric model is nothing but, in a regression model we are including either the lagged values of the independent variables or lagged values of the dependent variable as additional explanatory variable. Okay, so when we do such kind of, or when we include such kind of additional explanatory variable, very often we cannot estimate, or there may be problem with estimating this kind of an equation using your OLS. Okay, so how we can rectify such kind of a problem associated with OLS when we have a dynamic econometric model? That is deal with the second chapter. In third chapter, in last module, in last semester, we have discussed in detail the dummy variable regression model. Okay, so when we discuss the dummy variable regression model, we have considered only one type of a model, that the independent variable is in dummy format, not the dependent variable. But there are occasions, especially in qualitative research, where we have to consider the dependent variable as the qualitative. Okay, so in such cases, how we can, or when our dependent variable is in dummy format, it is known as dependent dummy variables or a qualitative response models. Okay, so how we can deal with such kind of a econometric model. The fourth chapter, we are introducing the time series econometrics. Okay, so when we discuss different types of data, we have told that, or I have told you that there are spatial econometrics, time series econometrics, and panel econometrics. Okay, so all these econometrics ideas or concepts are related to what type of data you are using in econometrics or in analysis. Okay, if you are using cross-section data, you have to follow certain steps, or you have to follow certain methodologies. Okay, the similar methodology you cannot apply into time series due to peculiar feature of time series data or peculiar properties of time series data. Okay, so how you can estimate a time series econometrics models, you see, oh, what are the properties of a time series econometric models, and what are the cautions that you have to be taken care when you estimate or when you deal with time series econometrics models. Okay, and how you can solve uh, the problem of spurious regression and non-stationarity in time series data, that we will deal with in the fourth module. The fifth module also, we will continue with our time series analysis, but we will stick on into univariate time series analysis. That means how we can forecast a variable with only one variables. Okay, so there are for that there are lots of different methodologies are there. The most prominent or most popular methodology is the ARIMA models. Okay, so in this chapter we will deal with ARIMA models. Okay, so apart from this, there are large number of different econometric methodologies are there, like VAR methodology and methodology that to deal with high frequency data such as arch and gauge models. A different family of gauge arch models are available. Okay, so if we have, then ARDL model is there, then DCC type of gauge, multiple gauge models are there. Okay, so if you have a time, it is all these topics are not there in your syllabus, but if you have time, then I will discuss all this kind of methodologies. Okay, and the last chapter is how we can practically apply all these methodologies into real economic theories. Okay, and you have learned many economic theories in your last three semester, like three semester from different branches of economics. From macroeconomic you have learned, sorry, from microeconomic you have learned the demand functions. Okay, Engel curve, cost curves, and production functions, Coptegraph and CES, how you can estimate this type of a model using econometrics. Okay, then in macroeconomics, demand for money, inflation output trade-off, Phillips curve, and natural rate of unemployment, how we can empirically verify all these theories, that we will learn. Okay, then if you come to public finance, there is a Wagner's law of public expenditure. Then elasticity of taxations. Okay, when you come to international trade, there is a export-led economic growth or J-curve effect. The large different types of theories are there. All these theories can be empirically verified. using a set of econometrics tools. Okay, so in this chapter we will do certain things, certain practical sessions on how to use econometrics models. Okay, yes. So in this chapter, uh, so what we do is we will start with the second chapter because we have already learned what is this AR model and what is this what is this DLM model, a distributed lag model. Okay, and we have also see how we can how a Koyak model, what is the Koyak model and how we can derive the Koyak equation and all. Okay, so in this chapter also the first heading is, if you look at the syllabus of your second chapter, you can see that it is starting from Koyak approach to distributed lag models. Okay, so we have already seen the Koyak models. Okay, so what I'll do is I will discuss the Koyak approach first. Okay, then there are certain problems with the Koyak model. Okay, so how we can incorporate the effect of adaptive expectation and partial adjustment effect to into how we can bring these two effects into Koyak equation. Okay, then uh, since there are certain issues with these two equations, uh, Almonds, he has brought a model called Almonds polynomial models. Okay, then how we can estimate the autoregressive model using method of instrument or instrumental variable method. Okay, then what is a Granger causality test? These are all the topics that we will cover in this particular chapter. Okay, so we will start with the second chapter, then we will come to the first chapter. Okay, yes. So in this chapter, first we will discuss what is the dynamic econometric model. Then, as you know, that the dynamic econometric model can be of two types: distributed lag model and autoregressive model. What are these two models? Okay, then why we need a lagged variable in our equation? What are the reasons for using the lag and what is the lag? Okay, and third thing is how you will estimate this equation, or how you will estimate a distributed lag model using Koyak model, adaptive expectation and the partial adjustment model, then Almond's polynomial lag models. Okay, then there is an instrumental variable model, and last portion is the Enkel-Granger causality test. Okay, so these are all the topics that we will cover in this chapter. Okay, so first I will discuss with you what is a dynamic model. Okay, so this dynamic model, or if you use a time series data, you know what is a time series data? A time series data is a data which is ordered on the basis of time. That means you have a yearly data, or you have a monthly data, weekly data, daily data. These are all certain kinds of time series data. Okay, so if you look at a time series data, we can construct three different types of a econometric model. The first model is a model with only current explanatory variable and a dependent variable. In your model, two different types of variables are there. One is the dependent variable, one is the explanatory variable, which are contemporaneous or which are current. That means you are not including any lagged values in your model. Okay, y is equal to alpha beta 0 plus beta 1 x t plus ut. This is the example of this kind of a model. Second model, a model with current explanatory variable, lagged explanatory variable and a dependent variable. In this model, you have a variable called yt, okay, then your current explanatory variable xt, then your lagged explanatory variable xt minus 1. Okay, so this is the second type of model, and the last type of model is, in your model there is a dependent variable, there is an explanatory variable, current explanatory variable, then there is a lagged dependent variable. That means yt is equal to beta 0 plus beta 1 xt plus beta 2 yt minus 1. Okay, so this is what is called these are three different types of model, and fourth type of model are there, where you will have dependent variable, explanatory variable, lagged dependent variable, and lagged independent variable. That means yt is equal to beta 0 plus beta 1 xt plus beta 2 xt minus 1 plus beta 3 yt minus 1. Okay, so this type of a model is known as ARDL model, that we will come to later. Okay, so in these three models, the first model is known as a static model. Okay, you might have learned static and dynamic equilibrium. What is static model? A static model where only current values will have an impact on your dependent variable. Consumption depends on my current income. Okay, quantity demanded for a commodity depends on current prices. Okay, so this type of a model is known as static model. Okay, whereas the second and third models are not the static model, but it is a dynamic model where the lagged values of explanatory variable or lagged values of dependent variable will affect the dependent variable. Consumption depends on past income or previous income, or consumption depends on permanent income. Okay, or consumption depends on previous level of consumption. Okay, or quantity demand for a commodity depends on previous level of prices or previous level of purchase. Okay, so this type of a model is known as a dynamic model. Okay, so I hope you know the difference. What is the difference between static model and dynamic model? In static model, only current values will affect the dependent variable. In dynamic model, the past values of the dependent as well as independent variable may affect our dependent variable. Okay, now in econometrics and finance, also in international trade, the lagged value plays a very crucial role. As this lagged value, the importance of the lagged values, we can see mainly in macroeconomics and finance. Okay, and some of the international trade theories also you can see its importance. Okay, so what is meant by a lag? A lag is nothing but lapse of time. Which means that, okay, why we consider or why we incorporate this lagged values in macroeconomics or finance models, because in this macroeconomics and finance econometric models, or in this kind of a theories, a variable y will take time to respond for a change in x. Okay, so a variable will take time to respond for a change in x. If something happened to x, okay, immediately the y will not respond, but y will take time to respond. If you look at the recent demonetization policies by the Narendra Modi government, okay, So it was a policy, it was a macroeconomic policies. Okay, so the policy has implemented 1 year back, but the effect has been happened 6 months later. Still the effects is going on. Okay, so if you are including a macroeconomic, if you are using a macroeconomic model, okay, you have to model a macroeconomic model using this kind of a lagged models. Okay, similarly in finance, as you know that this uh, commodity market prices will affect the financial market. For example, gold prices, then oil prices, all these models will affect, all these kind of commodity market prices will have an impact on your stock market, or stock market index will be reflected this kind of a price hikes. Okay, so as you know that in recently in the aftermath of this corona pandemic or COVID-19 pandemic, one day in the history, the world Texas intermediate prices for oil has become negative. I hope you have got this news. Okay, which means that if you want to buy petrol, if you want to buy this oil, you don't need to pay any money. They will pay money to you in order to buy this crude oil. Okay, so this happened not in the spot market but in the future market. Okay, so such kind of an impact, such kind of a negative oil prices will impact the exchange rate, will impact the stock market all over the world, but not immediately, but it will take some time. After 1 day, after 2 day, after 3 day, it will have impact. Okay, so when we model this kind of a relation, stock market is depends on oil prices. Okay, stock market is not depends on current oil prices but the previous oil prices, oil price after 2 days. Or if you look at the gold prices in stock market will have a negative impact as this both things are these asset prices. Okay, so whenever something happens to international gold prices, the country's stock market will be responded. Not always necessary or not immediately, but it will take some time. Okay, so because of these things, we usually include a lagged model in our macroeconomic or finance models. Okay, and the major reason for this kind of a lagged variable, this kind of an inclusion of a lagged variable in our model is threefold, or three reasons are there. One is psychological reasons, technical reasons, and institutional reasons. Okay, so in all these type of reasons, it says that there will be a time lag in everything. Okay, first time lag is time lag in believing something. If suppose, as you know that this demonetization happened, okay, so we didn't believe that it will have an impact on our day-to-day life, but later on after 1 month or after 1 to 2 months, we believed that, or we have experienced that this policy is impacting each and everyone in this economy. Okay, so in order to believe this impact, it took 1 to 2 months. Okay, so it always takes time to believe a policy changes. You will not believe a policy change until it will come to you. Second, technical reason or technological reason, Okay, so especially in a firm or industry, if a new technical changes happen, okay, so it will take some time. If there no, suppose in banking technology they have introduced this mobile banking, okay, but still the people don't have this mobile banking facilities, okay, so it will take the time to implement this kind of a technical progress or technical changes. It will take some time. Or in a industry or in a firm, if they want to replace a machine with a new machine, it will take some time. Okay, then the third one is the institutional reasons. Since all these policies are implemented by the governmental agency or some private agencies, no, it will take, they have to prepare some rules, regulations, notice and contracts. For all these things it will take some time. Okay, yes. Okay. So these are all certain reasons for including uh, a lagged variable in our models. Okay, so what's the problem is, actually, for example, if you take a salary person, you take my cases, I have expenditure in this current month, okay, but I'm not getting salary. I'm getting salary only after 1 month, okay. So I am not getting salary in initial days of month, but instead I'm getting the salary after 1 month, okay. But I have expenditure, I have to incur my personal and family expenditure. So my current consumption is not depends on my current income, but my previous income. Okay, so but when you have not considering this fact and you have prepared a model, your model will be a misspecified model, or you are committing a specification mistakes or specification errors. Okay, then as you have seen in the previous semester, if the specification error happens in your model, then it will violate one of the assumptions of Euler's, and it will make some problems in your estimation as well as your uh, significance. Okay, yes. So what we have to do, we have to include a lagged values or lagged variable in our model if the lagged values is having any kind of importance. Okay, so in order to uh, make you, no, in order to make my point, let me take a celebrated uh, consumption hypothesis, permanent income hypothesis, put forward by Milton Friedman. You are all learned this hypothesis, Milton Friedman consumption hypothesis. What this hypothesis says: current consumption expenditure of an individual or a household is a function of his or her permanent income. Okay, that means he has restated some of the previous uh, consumption theories. Okay, so in previous consumption theories, like Keynes, they have told that consumption is depends on this current income. But Friedman says that current consumption is not only depends on the current income, but a permanent lifelong income. Okay, but the problem is, how does one measure the permanent income? Current income can be easily measured. Okay, but how can we measure a permanent income? What the Friedman has done, he has took a quarterly data, or based on quarterly data, Friedman estimated permanent income as a weighted average of quarterly income going back about 16 quarters. Okay, so the permanent income is measured by Friedman, okay, by taking a weighted average of actual quarterly income of last 16 quarters. Okay, so he has measured the permanent income on the basis of current income, not only the current income but also the past 16 quarters current income. And he took an average of these things, and this average he called as a permanent income or lifelong income. Okay, so for Friedman has this kind of a model where YT consumption depends on current income, previous first quarter income, second quarter income, third quarter income, up to 16 quarter income. And he took an average of all these things and he called it as a weighted average of, he called it as a permanent incomes. Okay, yes. So in almost all the theories, especially in macroeconomics and finance, we will use this kind of a ideas or this kind of a Laggett models. Okay, now we come into the dynamic econometric model, and dynamic econometric model can be of two types. The first one is the distributed lag model, and second one is the autoregressive model. The difference lies in one fact: whether a model is distributed lag model or autoregressive model will lies in one fact, that whether you are including lagged explanatory variable or lagged dependent variable as additional explanatory variable. Look at this equation. Yt is equal to beta 0, beta 1 xt, beta 2 xt minus 1. In this model, we are including the lagged values of independent variable as additional explanatory variable. So this is model is known as distributed lagged model. Okay, whereas if you look at these equations, yt is equal to beta 0, beta 1 xt plus beta 2 not xt minus 1 but yt minus 1. Here we are including the lagged values of your dependent variable as additional explanatory variable. Okay, so this model is known as autoregressive model. So what's the difference? The difference is, if you are including the lagged values of your independent variable, it is distributed lag model, or if you are including the past values of your dependent variable, it is called autoregressive model. Okay, now the issue is suppose we have a distributed lag model or autoregressive model, how we can estimate these models? Can we estimate this model in a similar way that we have estimated our static model? Can we do it? No, we cannot do it, since there is a extra variable is happening in our extra variable is appearing in our models. So there are certain issues associated with these models. Okay. So let me take a distributed lag model first, then we will discuss the autoregressive model. So a distributed lag model will look like yt is equal to alpha plus beta 0 xt plus beta 1 xt minus 1, beta 2 xt minus 2 up to beta 2 beta k xt minus k plus ut. This is an example of a distributed lag models. Okay, so in this model we will have three different types of parameters. Broadly, there will be two types of parameter, like intercept and the slope parameter or partial slope parameters. Okay, then if you look at these slope parameters, here there are three different types of parameters. First type of parameter is known as short-term parameters or immediate effect parameter. Okay, second one is the intermediate, third one is a long run parameter. So what will be the short run parameter of short run effect? That means this example is yt is a function of xt and past values of xt minus 1. What this model says? It says that yt xt depends on xt influence yt, xt's past values will also influence yt, okay, and not only for a particular day, it is affecting many days. It is affecting, suppose if it is month, if it is daily data, then many days past values are affecting the y. Okay, yes. So what is the immediate effect? That means yt is a function of xt. If something happened to xt, yt will also change. Okay, so what is the coefficient of your current xt? That will give us the immediate effect of change in yt due to change in xt. Okay, suppose if there are beta 0, beta 0, beta 2, beta 3 up to beta k, or suppose it is there are 16 lagged values are there, and I am just taking beta 0 plus beta 1 plus beta 2 beta 3, only 4 variables. So it will give us an intermediate multiplier or intermediate effect. Okay, then if I am taking all slope coefficient and if you are taking a sum of this all coefficient, suppose there are 16 lagged values, if I am just summing all the 16 values, okay, then it will give us the long run multiplier. Okay, so in the lagged models, there will be intercept and slope, and the slope can be short run slope, intermediate slope, and long run slope values. Okay, so it is known as short run multiplier, intermediate multiplier, and long run multiplier. Short run impact, intermediate impact, and long run impact. Okay, yes. Now estimation of this dynamic model. Okay, so the estimation, how we can estimate this type of a distributed lag model, that we will discuss in the next video. Okay, okay. So thank you.